This is video number 3 for sections 3.5 and 11.1, solving absolute value equations. This is another extension of what we've been doing with linear functions. You've probably seen these vertical bars before. They're called absolute value. And in math, we use these vertical bars when we want to talk about not the entire number, but just the value part of the number. In other words, if we want to ignore the sign. So I don't care whether it's positive or negative, I just want to know what's the value portion of the number. The official definition of absolute value I've got written here. It stands for, technically, how many steps you would have to walk from 0 to that number on a number line. It doesn't matter whether you're moving to the left or to the right. So you can ignore left and right. You're just counting spaces. So as a couple of very simple examples, this is read the absolute value of -4. And like I was saying, I just think of it as, well, if I strip away the sign, what's left? Well, if you take off the negative, then the only thing left is the 4. The absolute value of -4 is 4. That's the value portion of the number. If you're a visual person, you could do it the counting steps way. If here's 0 and here's -4, you're basically just being asked, if I was walking from 0 to -4, how many spaces would I have to go? I'd have to go 4 spaces. How about absolute value of +3? Well, if you take off the positive, all you're left with is 3. It's the value portion of the number. Again, you could count that out on a number line. In order to walk from 0 to 3, it would take you 3 steps. 1, 2, 3. The only kind of strange one is 0. 0 doesn't really have a sign to strip off. But I mean, if I started at 0 and I said, well, how many steps is it going to take me to walk to 0? It wouldn't take me any steps. It would take me no steps. I think a lot of people remember this as, oh, everything turns positive, except in the case of 0. And that's okay, but I would encourage you to really focus on this, that what you're giving is the value portion of the number. Watch how that helps in these problems, because the goal in this video is to solve an equation that has one of those absolute value statements in it. And the question is, how do you deal with that? To be honest, it's a little tricky, because it's hard to figure out how to get rid of those vertical bars. I've given you kind of the main steps over here. You always start by just getting the absolute value part of the equation by itself. Okay, get rid of all the other outside stuff. And then there's not really an algebra step for getting rid of the bars. And I think that's what bothers people about this. It's really more of a thinking step and using that idea of value. So I will show you. Okay, take a look at this example problem. What's between the 3 and the bar? It's an understood multiply, kind of like when you have a 3 next to a parentheses or something like that. So I want to get that vertical bar part by itself. It's going to take me a couple of steps. I'll have to add 6 to both sides. And then I will have to divide out both sides by that 3. And so the vertical bar part is now sitting there alone. That was step 1. Isolate that absolute value. Okay, now that I've done that, here's the way to continue. Here's the way to think about what happens next. It's a thinking step more than an algebra step. Whatever's in the bar is trapped in there at the moment. I want you to think of it as some mystery number. I've got this mystery number, and I don't know what the mystery number is, but I do know that the value part of the mystery number is 5. That's what this equation says. The value part of that mystery number is 5. So then off on the side, I can say, well, let's see, where could I find numbers whose value part is 5? Well, look, there's only 2 places you can go. You can either walk 5 spaces to the right, or you can walk 5 spaces to the left. Those are the only 2 numbers that have a value portion of 5. Okay, well, that's what I mean by list possibilities. My mystery number, therefore, must either be -5 or +5. Well, I'm done. That's the solution to the equation. I should say solutions, right? There are actually two different numbers that you could plug back into the original equation in order to make it true. You get rid of the bars by doing this thinking step and listing possibilities. Let me show you one that's just a little bit more involved. So here's a second example. Same task, solve for x. It's got the absolute value bars. First step is probably obvious. I need to get those bars by themselves. So there's only one reason it's not by itself right now, and that's that 2. So I'm going to divide both sides by 2. So that'll give me absolute value 3x plus 1 equals 4. And then, I know when students are first learning this, the tempting next step is to say, oh, I better subtract 1 from both sides. Well, you can't do that because this 1, this 3, they're all trapped inside the vertical bars. And until you get rid of those, you really can't go any further. How are you going to get rid of them? By thinking in terms of mystery number and value and then listing the possibilities. Notice my mystery number is a little bit more complicated this time. It's the entire 3x plus 1. I have no idea what that mystery number is, but I do know that the value part of that mystery number is 4. So I go to a number line. I think, well, where could I be? There's two choices. Either I'm on the left side or I'm on the right side. Those are the only two numbers that have a value portion of 4, -4 and +4. Another way to say it is, if I want to walk 4 spaces, there's only 2 places I can end up from 0. At -4, 4 spaces to the left, or at +4, 4 spaces to the right. I use that in order to list my possibilities for the mystery number. So my mystery number 3x plus 1 could be -4, or my mystery number 3x plus 1 could be +4. Mystery number and value. Once the bars are gone, now you can touch the 1 and the 3 and all those normal algebra things. In fact, you're going to have to do it twice in order to get the solution. This number line that we drew right here is not part of the answer. It's just a tool we're using to help us identify those possibilities for the mystery number. Okay, now we're almost done. Just do the simple algebra steps. Subtract 1 from both sides in both cases here. And that's going to give me, let's see, a 3x equals -5 here, and 3x equals 3 for this one. And of course, divide both sides by 3. And I'll end up with my two values of x. You might say that we essentially looked at this problem as having two mystery numbers. I mean, we wanted to solve for x, but before we could ever do that, we had to essentially figure out what 3x plus 1 could be equal to. And then we were able to take it down and figure out the values of x. Don't lose sight of what we're saying here. If you go back to the original equation, we're just saying that either of these two numbers, if you were to plug them in and work out the math, either of these two numbers and only these two numbers would make this equation true.